Hi, I'm Tasya Septiani, Mechanical Engineering 2019, and today I'm going to present the report of my experiment for Senior Mechanical Laboratory that I have done for the past one semester. Enjoy! This presentation will be divided into 5 parts for each experiment. First is the preparation, second is the assembly, third is the experiment, fourth is the analysis, and the last will be the conclusion. For the first part, which is the preparation, I will just make it into one that summarizes all the 3 experiments since they are all the same in this part. The first thing that needs to do as the preparation is to do the research. Research is the process where I look for sample questions that can be converted to experimental forms in real life. Second is choose. At this step, I have to start listing what items or components that are needed to build my experiment's overall setup. After listing all the components needed, I need to sort and select the items to be purchased with the following criteria. The first is availability. The availability of the item is essential or important. If the selected item is not available in the online nor offline store, so I must immediately look for an alternative. Due to limited time and space because of the COVID-19 pandemic, this criterion is essential, which is the availability. And then the second one is the size. Size. Each item or component's size is important to pay attention to, especially during the assembly process. You cannot choose or make a setup that is too big because it will complicate the shipping process. And for shipping, there is a maximum price that must be achieved, so the size really needs to be considered. The third one is cheap. Due to, limit, Due to limited funding, I have to choose as cheaply as possible with sufficient quality of components, so I do not need to buy the new one if it is broken. The last one will be flexibility. Each component must be as flexible as possible to unite with other so that later it is necessary to build a complete setup. The first experiment that I'm going to explain is thermodynamics. Yeah, from thermodynamics perspective, the experiment can determine how many energy in joule into the system went to system to generate the sorry, to generate phi and left the system. By applying efficiency is equal to W over QH, and then the N type of semiconductor allows electron to move from hot plate to cold plate, and P-type of semiconductor to do the otherwise. Now is the assembly process for this thermodynamics experiment. The first thing that need to be done is the thermoelectric. The assembly process is as follow. I have to prepare the surface of the metallic plate by applying thermal paste to the surface of Peltier generator, which is the thermoelectric, and assemble it on the plate. And it must lie on same side. So the next step will be secure all the location of the 4 thermoelectrics and put all the 4 thermoelectric generator in series by make sure that it is there is no blank space between them. And then I have to secure with electrical tape. Next is to assemble the whole setup. The first one that I need to do is put the wooden block to hold the metallic plate high, and then I have to put the second plate on the top of the assembled thermoelectrics, that the one that I have assembled before. And then the next step is connect the last two cable, the alligator cable, and connect it to the LED lamp. And then on the below of the bottom plate, I have to put the heat source, which is from the candle, and on the top I have to put the ice as the cold reservoir. This is to create a temperature difference. The next one is the experiment. The experiment is quite easy to do. I only need to put two sources on the top and the bottom of the setup. The top is the cold reservoir. Here I use the ice, while the bottom is the hot one or candle. Yeah, here I light it up, the candle. Basically, the objective of this experiment is to observe whether this setup is enough to turn on the light or not. The experiment that I have done is done quite well, and the light is successfully turned on. Now let's analyze the result of the experiment. The schematic of this experiment is as follows. It is known that the phi of one thermoelectric is about 0.93 volt, while the I is about zero point 0.1 ampere. But we need to achieve 5 volt for the voltage of the LED. So we need 4 thermoelectrics to support that. And here we can find the voltage of the 4 thermoelectrics become 5.059 volt, while the I is 0.1795 ampere. Now let's compute the known values. The basic formula is P equal to I times V, and then substitute all the values, and we got P is equal to 0.88975 watt. After that, we need to know the Qin using the formula of efficiency equal to V out over Qin, and it is known that the efficiency of the thermoelectric is 5 to 8.4%. Here I use 5%. So we can get the Q in is 17.8 volt. Here is the final schematic where the Q in is 70.8, and then the P that distributed to light up the light, the LED is 0.89 watt, and then the output will be 16.91 watt. The conclusion: the first one is the application from this experiment. I can know the application of thermodynamics principle in real life. And here all the experiment and analysis is done. From here I can conclude that the application of thermodynamics in real life is applicable. And then the second one is the experiment did not go very well at the first trial, because when I tried to turn on the red light won't turn on. I can conclude that there might be some error with the light, so it doesn't want to turn on. The last one will be the experiment is applicable for home-based experiment because it is simple to do. The second experiment is for fluid mechanics. This is the basic principle for this experiment, which is Bernoulli principle. The principle used here are Bernoulli's Bernoulli's equation and conservation of energy, then we could determine the water flow or velocity from the reservoir through point A and through point B with the height difference, water height difference at A and at B. To build up the whole setup, I need to do the assembly process. First, I need to cut the bottle and make a hole for the straw, and then I have to glue the straw to the bottle, and then I have to make 2 points and record the height from point A to the straw and from point B to the straw. Here is the experiment process. Basically, it is only need to fill up the bottle using water until it reaches point A. Then I need to observe the output of the water flow. And then I have to do the same thing for point B. I also have to observe the behavior of the water flow at the end from point A and also point B, like this. So here is the comparison for the water flow resulted in point A and also at point B. Now let's do the analysis. This is the basic equation that used for the analysis. First is the Bernoulli equation, and from here we can compute it into the water flow equation to observe the V out resulted by the height difference. Analysis at point A. Point A is placed 12 cm from the bottom, while the straw is placed 6.5 cm. So from here the height difference, which is h1, is ha minus hs equal to 12 minus 6.5. So h1 will be 5.5 centimeter. So here we know that h1 is 5.5 centimeter, and then now we compute it into the formula of V out. V out equal to square root of 2gh1. So the V out will be like this. We put everything here, and then we can get the value of V out is 0.33 meter per second. Now analysis at point B. Point B is placed 23 centimeter from the bottom, and we know that the edge of the straw is 6.5 centimeter from the bottom. So the height difference, which is h1, is 16.5 centimeter. H2 is 16.5 centimeter, and then we compute into the formula of V out, which is square root of 2gh2, and we plug everything in here, and then we can get V out is equal to 0.57 meter per second. Now is the conclusion. Uh, by this experiment, I can know the application of Bernoulli principle in real life. And then I can conclude that the result is just as what I expected, which is the relation between the height difference and the V out. As the height is getting higher, the velocity of the output flow is higher as well. And then the third one is the experiment went so well. There is no error occurred during the experiment. And the last one, I can conclude that the experiment is applicable for home-based experiments since it is very easy, and the components needed to build the setup is also so easy to find. So it is so applicable for home-based experiment. The last experiment is heat transfer experiment. Here is the principle of this experiment, which is the heat loss or gain results from a pipeline with a fluid that is hotter or fluid or cooler than ambient temperature. And then the insulation here I use the foam, prevents the leak of heat or heat loss to the environment. Heat loss depends on a variety of variables such as insulation thickness, here the R3, and then the temperature itself, the temperature which is the it's infinity 1, T infinity 1, and etc. The equation below is illustrate how heat loss from an insulated pipe and a bare pipe to the surrounding environment can be measured. We can use this formula to compute the analysis later on. Assembly process for heat transfer experiment. So what I need to do here is first I need to cut the pipes to a sufficient size, which is these pipes, and this also this, and then this. And also I have to make a hole on the bucket as the water reservoir based on the pipe diameters, which is 3.4 inch. And then I have to insulate one of the pipe, which is this one. I insulated one of the pipe, and I have to punch holes in the end of the two here to place the digital thermometer and give the PVC glue to close the hole. Now I have to assemble all the pipes using knee pipes and pipe glue so that it can build such a water flow. And then I have to I have to make sure that the height of these two pipes is equal so that the water can flow very well. So here is the quick video of the experiment. Actually, I only need to prepare a warm water as the water reservoir. Then I have to record the temperature. Here I got 40.4 degrees Celsius. Then I let the water goes down through two pipes, the insulated and non-insulated, and record the temperature of the water at the output. I got 39.1 degree Celsius for the insulated, and I got 38.3 degrees Celsius for non-insulated. After I got the parameter needed, now is the time for the computational part, which is the analysis. The parameter for the pipe is I measure the length of the pipe is 80 centimeter or 0.8 meter, and then I measure the R of the pipe itself. The R1 is from the middle into the inner inner radius, and then R2 is from the middle into the outer one, and then the R3 is from the middle until the insulator, which is the foam. Here R1 is 4.54 centimeter, and R2 is 4.8 centimeter, where R3 which is 6.8 centimeter. Here are the other parameters needed, which is the age of the pipe, the age of the insulator, the K of pipe, K of insulator, and then the temperature that we have recorded before. And here I got the parameter from the source that I have included in this file. Now is the computational part. First, I need to compute the area for the pipe, which is A1. The formula is 2 pi R1L, and we already know all the parameters, so we only need to plug plug it in, and we got A1 is equal to 0.23 meters square. And then A3, just using the same formula like A1, and we compute everything, we got A3 is equal to 0.34 meters square. And now is the thermal resistance. The formula for thermal resistance is here. Formula for R input, which is the R convection one, is 1 over H1A1, and we just plug everything in. We got RI is 0.869 Kelvin over watt. And then the formula for R1, which is R pipe, is ln R2 over R1 over 2 pi K1L. We know all the formula, all the parameters, we plug it in, and we got R1 is 0.059 Kelvin over watt. Next is the formula for R2, which is R insulator, is ln of R3 over R2 over 2 pi K2L. We know the parameters, we plug it in, and then we got the value of R2, which is our insulator, is 3.01 Kelvin per watt. And the last one is the R for the output, which is convection tool. The formula is 1 over H2A3. We know the formula, we know the parameters, we plug it in, and we got RO is 1.7 Kelvin over watt. Since the analysis is in series form, so to find the total resistance, I only need to sum up all the found values for the Ri, R1, R2, and RO, and I got the R total is 5.638 Kelvin per watt. After knowing the R total and other parameters, now I have to compute them into the heat loss formula. The heat loss formula is R equal to T infinity 1 minus T infinity 2 over R total. So here the heat loss of non-insulated pipe is 55.36 watt, while the heat loss of the insulated pipe, the insulated, while the heat loss for insulated pipe is 55.22 watt. So from here, I can conclude that the application of I can learn that the application of transfer heat transfer principle in real life is applicable. And then the experiment did not go very well because that pipe is leaking, and then the result is not as expected at the first trial, where the non-insulated pipe has higher heat loss than the insulated one. And it may happen because there is a heat difference between the two pipes, which may cause the water flow at the non-insulated flow first, and then after that it flowed in the insulated one. And the last conclusion that I can get is this experiment is also applicable for home-based experiments since it is so easy to do. So the feedback, I'm very glad to have a chance to conduct such experiment at home, where I have to do my best to design the setup, build the experiment, buy the components, and record the data needed by my own. And it is quite challenging actually to do this kind of experiment at home, because I'm always inhibited by laziness, even though the experiment can be done once a day, but because the experiment was at home and I was so lazy, it took me a little longer to finish it. And I also want to thank Mr. Jati, who is always responsive when I need help or there is any errors in my experiment. Thank you so much. Thank you. And also thank you for understanding my situation as a student by being patient even though I am lazy. Overall, it was a very fun experience that I have had. Thank you so much for your attention and see you when I see you.